These days, it seems that wherever we look, there are digital devices, all the way from our computers to our doorbells. But have you ever stopped to think what these words really describe? Analog comes from the Greek word analogos, meaning proportional, or in electronics, something that is continuously variable. On the other hand, something that is digital only has two states. In electronics, it's a high and a low voltage, or in computer language, it's ones and zeros. Most things in nature are analog. Think of a door. It can be fully open or fully closed, but it also exhibits a whole lot of values in between. But most fundamental electronic components like resistors, capacitors, or rheostats are analog. Digital circuits use only two logic levels, a high voltage and a low voltage for signaling. The high voltage may be anywhere between 1.8 volt and 5 volt, while the low voltage may be 0 volts. So an analog signal may look like this, while a digital signal like this. Computers operate on a binary system, which means that they only understand two values, ones and zeros. Any number or letter in the alphabet can be described using just these two numbers. Number 13 in binary is 1101. How did we get there? Well, there's a system which converts every number to ones and zero, but we'll not go into that now. Then there's a system which converts every keyboard symbol to a number using the ASCII system, and that stands for American Standard Code Interchange. So, my name, Joe, J-O-E, translates to numbers 74, 79, and 69, which in binary is 1001, 0101, 00, 11, 11, 11, 000, 101. Whew, wow! Remember that computers are so fast and makes these conversions in a jiffy. But what on earth does this have to do with trucks? Well, a lot. Traditionally, vehicles carried power and signals around the chassis with discrete wires, leading to huge wire looms with miles of wires. The analog sensors and devices around the truck carried these discrete signals at various levels of current to transmit signals and power to various devices, lamps, and relays. Today, digital systems use a central wiring backbone with two wires for high and low signals transmitting digital messages. Sensors and devices around the chassis are wired into this backbone. So instead of using discrete wires to carry signals, vehicles now have CAN systems, stands for Computer Area Networks, into which electronics devices are hooked, allowing them to communicate with each other. This is like the old party line telephone systems that were used years ago. While engines and emission systems have their own networks, the one most commonly used for general chassis connectivity is the SAE J1939 protocol. The messages are digital, meaning that they use the binary code to transmit the coded messages which are interpreted by computers and devices on the chassis. Since these messages are carried over shared wires, it means that wiring systems have been greatly reduced. Since analog systems can be checked with simpler tools like multimeters, they're easier to diagnose and repair. Digital harnesses have far fewer wires, but they do require more sophisticated diagnostic tools. As vehicles become more digitized, with more and more sensors on board, these harnesses will be reduced in both weight, complexity, and cost to the benefit of everybody.